Hi guys, welcome back. Today we'll talk about the roots of the equation, um, how the roots are real or different and real, or equal and real, or complex and not real. I will show you how does it work. Of course, you know the formula of the quadratic equation: x is equal to negative b, positive or negative, the square root of b squared minus 4ac divided by 2a. Well, what about the amount underneath the square root, b squared minus 4ac? In fact, this is called the discriminant. And according to this discriminant, we can say that the roots are real and different, or real and equal, or complex and not real. So let's suppose that we have x is equal to, for example, 2 plus or minus, and the discriminant was the 25, for example, 25. So the square root of 25 divided by 2 times a, let's suppose it's 3, for example. All right. So here, the square root of 25 is 5. So we have different real numbers here because it's the 2 plus or minus 5 divided by 3. Once it's 2 plus 5 divided by 3, and the other root is 2 minus 5 divided by 3. So here we have two different real numbers. This is called a root, and this is another root, but they are different because this one is plus 5 and this one is minus 5. So we can say that the first case here, according to the discriminant, b squared minus 4ac, the first case here when it's positive, all right? I mean, it's greater than 0. Now we have two different real roots, or we can say real and different. All right, this is the first case. What about the other case? The other case when b squared minus 4ac is equal to 0. Like in the previous example, if I say positive or negative, the square root of 0, of course, you will delete this amount and you have left with negative b divided by 2a. That means it's just one root, or we can say two equal roots. So they are real, and equal. All right. And the third case, when b squared minus 4ac is negative, I mean, it's smaller than 0. I mean, when you have this amount, b squared minus 4ac, or the discriminant is less than 0 or negative. Now we have an imaginary part here because it's negative underneath the square root. Like negative 25, the square root of negative 25 will be, the square root of 25 is 5, but you have negative underneath the square root, it will be I. You remember, the square root of negative 1 is I, so it's 5i. So now we have a complex number, but it's not real. So complex, but not real. All right. So the first case, when the discriminant is positive, so it's real and different. This is the first case. The roots, or the two roots, are real and different. And the second case, when b squared minus 4ac is equal to 0, or the discriminant is equal to 0, the roots are real and equal. And the third case, when the discriminant is negative, so the roots are complex but not real. These are the cases of the discriminant. Determine the type of the two roots of each of the following equations. X squared minus 2x plus 5 is equal to 0. Now, to determine the type of the roots, we have to get the discriminant. If the discriminant is positive, that means we have two different real roots. And if the discriminant is equal to 0, that means we have two equal real roots, which is basically, it's one root, in fact. And the third case, if the discriminant is smaller than 0, so we have two complex but not real. So let's see if the discriminant is positive or negative or is equal to 0. So here we have a, which is the coefficient of x squared. So the coefficient of x squared is equal to 1. So we can say that a is equal to 1 and b is equal to, which is the coefficient of x, is negative 2. And c is the coefficient or the absolute term, which is 5. So c is equal to 5. Now, what is the discriminant? The discriminant is d is equal to b squared minus 4ac. Now, let's plug in all these values in the formula of the discriminant, b squared minus 4ac. b is negative 2, so negative 2 all to the power of 2 minus 4 times a, which is 1, times c, which is 5. And let's do the math. Negative 2 squared is equal to 4. Negative 4 times 1 times 5 is equal to negative 20. So 4 minus 20 is equal to negative 16. Now the discriminant is smaller than 0, which is negative. That means we have, you remember, they are real or not real. Yeah, it's smaller than 0. That means we have two complex and not real. So complex, the two roots are complex, not real. All right. In this example, determine the type of the two roots of each of the following equations. X minus 2 over x minus 1 is equal to 4. All right. So let's change the equation because we have the denominator here, x minus 1, and we have to get rid of this denominator by multiplying by the same denominator, which is x minus 1. So multiplying the whole equation by x minus 1. So the left-hand side, which is x, you'll multiply all by x minus 1. All right. So here x, and then minus 2. I will rewrite the equation, x minus 1 here down, and is equal to 4. Now I will multiply the whole equation by x minus 1 because you need to get rid of this denominator. So here multiplied by x minus 1, and here multiplied by x minus 1, and also here on or in the right hand side multiplied by x minus 1. All right, so x times x is x squared minus x times 1 is x, and then here x minus 1 down and x minus 1 up, they cancel each other out, so you have left with negative 2 is equal to, and here you can distribute 4 into this parenthesis. So 4 times x and then 4 times negative 1. 4 times x is equal to 4x, and then 4 times negative 1 is equal to negative 4. Now here you have x squared minus x minus 2 is equal to 4x minus 4, I mean. So you can move 4x minus 4 to the left-hand side. So x squared minus x minus 2, and 4x will be here with negative, so negative 4x, and negative 4 will be here with positive, so plus 4 is equal to 0 because you don't have anything here in the right-hand side. Now, where are the like terms? You have negative x and negative 4x. They are like terms because they are both having x. So x squared minus x and negative 4x is negative 5x. All right. And also you have another like terms here. You have negative 2 and plus 4. They are, 4 minus 2 is plus 2. So plus 2 is equal to 0. Now the equation in the form of ax squared plus bx plus c is equal to 0. Now you can get the discriminant and see if the discriminant is equal to 0, if the discriminant is greater than 0, or if the discriminant is smaller than 0. So here A is equal to, B is equal to, and C is equal to. A is equal to 1 because the coefficient here is 1 of x squared, and B is the coefficient of x, which is negative 5, and then C is equal to 2. All right, now let's substitute all of these values in the equation, or I mean in the discriminant. The discriminant is equal to b squared minus 4ac, which is b squared is negative 5, so negative 5 squared minus 4 times a, which is 1, times c, which is 2. So the discriminant is equal to negative 5 squared is 25, and negative 4 times 1 times 2 is negative 8, is equal to 17. And what about 17? 17 is positive or negative? Of course, it's positive, so it's greater than 0. Now, what about the roots? Are the roots real and equal, or real and different, or complex and not real? Of course, when you have the roots, or when you have the discriminant greater than 0, that means the roots are real and different. So here the answer. The two roots are real and different. Prove that the two roots of the equation 2x squared minus 4x or minus 3x plus 2 is equal to 0 are complex and not real. Then use the general formula to find those two roots. All right. Now here he said that they are complex and not real. You remember, complex and not real means the discriminant is smaller than 0, right? So the discriminant is negative. So he said that to prove that. So let's get the discriminant and see if the discriminant is smaller than 0 or not. So here a is equal to the coefficient of x squared is equal to 2, and b is equal to, which is the coefficient of x is equal to negative 3, and then c is equal to 2. Let's plug in these in the formula of the discriminant. The discriminant d is equal to b squared minus 4ac. All right, so b squared, which is negative 3, so negative 3 squared minus 4 times a, which is 2, and times c, which is 2 also. Negative 3 squared is 9, and negative 4 times 2 is negative 8, times 2 is negative 16. 9 minus 16 is equal to negative 7. So here the discriminant is smaller than 0, so that means they are, of course, complex and not real. So they are complex, not real. All right, this is the first part of the equation, or the first part of the question. Then use the general formula, or the quadratic formula, to find those two roots. So what are the general formula? You remember? X is equal to, all right, negative b, positive or negative, the square root of b squared minus 4ac divided by 2a. And notice that b squared minus 4ac is the discriminant. And of course, you got the discriminant here. The discriminant is equal to negative 7. So here, x is equal to, let's draw a fraction, negative b, which is negative 3, which is 3, plus or minus the square root of the discriminant. And instead of writing down the discriminant again and substituting again, you already have the discriminant. So is equal to negative 7. Divided by 2a, which is 2 times 2, because a is equal to 2, so it's equal to 4. All right, so it's equal to. And here you have a negative underneath that square root. That means you have I. So again, 3 plus or minus the square root of 7, and separate negative to be outside the square root. It will be I. The square root of negative 1 is I. So it's square root of 7i divided by 4. Now, here you have two roots. The first root, x is equal to 3 plus the square root of 7i divided by 4, or x is equal to 3 minus the square root of 7i divided by 4. Now, let's make sure that they are complex, not real. Yeah, of course, they are complex because they have I. In each one, they have I. I is the imaginary part here. So you have an imaginary part here in the first root, and you have an imaginary part in the second root. So these are the roots. And this is the other root. All right. If the two roots of each of the following quadratic equations are equal, then find the value of k. X squared plus 2k plus 3x plus k squared is equal to 0. Now it says that they are equal, the roots are equal. Let's remember the cases of the discriminant. Here the discriminant is greater than 0. You remember, if the discriminant is greater than 0, then you have the two roots. The two roots are real and different. And here, if the discriminant is equal to 0, that means real and equal. And if the discriminant is smaller than 0, that means complex but not real. Here he said that the roots are equal. Now here is the case. The discriminant is equal to 0 because they are real and equal. So here the discriminant is equal to 0. So the discriminant is equal to 0. That means b squared minus 4ac is equal to 0. But what are a, b, and c? Let's type a, which is the coefficient of x squared. Now here, the coefficient of x squared is equal to 1, so a is equal to 1. And b is the coefficient of x. Here is the coefficient of x, 2k plus 3 in the front of x. So b is equal to 2k plus 3. What about c? C is equal to k squared. So here c is equal to k squared. Now let's substitute these in the equation, or and the discriminant is equal to 0. So b squared, which is 2k plus 3 all to the power of 2 minus 4ac minus 4 times a, which is 1, times c, which is k squared. So minus 4k squared is equal to 0. Now, how to expand the parentheses? The first parenthesis, 2k plus 3 is equal, or all to the power of 2. 2k squared, and then 3 squared, and then 2k times 3 times 2. 2k squared is equal to 4k squared. And then 3 times 3 is equal to positive 9. And then 2 times 3 times 2k. 2 times 3 is 6. 2 times 6 is 12. So plus 12k, because we have k here. And minus 4k squared here, minus 4k squared is equal to 0. All right, let's simplify. You have 4k squared and minus 4k squared. They are canceling each other out. So you have left with 12k plus 9 is equal to 0. Moving 9 to the other side. So you have 12k is equal to negative 9 dividing by 12. So here divided by 12, and also here divided by 12. 12 and 12 cancel each other out. So k is equal to negative 9 divided by 12, which is equal to negative 3 divided by 4, because if you divide each term divided by 3, you'll get negative 3 over 4. Negative 9 divided by 3 is negative 3, and 12 divided by 3 is equal to 4. So k is equal to negative 3 over 4.